Welcome everyone to our map class. Today we will be doing this particular map. So today we are going to draw a geological profile and geological cross section along line AB for this map. So first we are going to analyze this map. The very first thing we see in the map is topography. So we can see the different values of contours. The maximum value of contour is 1200 feet and the minimum value of contour is 600 feet in this direction, and the maximum value is in this direction. So the highest elevation is in the northern region and the lowest elevation is in the southern region. So we can again deduce that minimum height of the area is more than 500 feet but less than 600 feet, and maximum height of the area is more than 1200 feet but less than 1300 feet, as we do not have the contours of 500 and 1300 feet in this particular area. Again, we can see the shape of contours, so that are indicating the variation in topography at different places. So we have hills and valleys. Then after seeing the contours and analyzing the topography, we see the structures present in this area. So we can see that there are some beds which are being truncated against a single trace. So whenever we have truncation of many beds against a single trace, that trace is trace of unconformity. So we have presence of an unconformity in this area, and we mark the unconformity by zigzag lines. So here we'll mark it. So this trace is in fact trace of unconformity. So because the beds are being truncated against trace, so this represents an angular unconformity. So if there is presence of one angular unconformity, it means there are two sequences in the area. So there are two sequences. Because we have presence of one angular unconformity, we have older sequence and we have younger sequence. So the one which get truncates is older sequence. So this sequence is older sequence, and the ones which are parallel to the trace of unconformity, they represent the traces of younger sequence of beds. Now let's analyze that how many beds are there in the younger sequence. So we can see from the lithological variations that we have 1, 2, 3, 4, 5, 6, 7 beds, 1, 2, 3, 4, 5, 6 and 7 beds. So we have 7 beds in the older sequence, and because one trace of bed is intersected by more than one value of contour lines, it means they are dipping beds. And in younger sequence, we can see the younger sequence is also dipping because one trace is intersected by many value of contour. It means that trace is lying at more than one height. That simply indicates that the trace is inclined, or that bed is inclined. So we have analyzed that there is unconformity, there is older sequence and there is younger sequence. Then we can notice in older sequence that there is a vertical or a straight line that is offsetting these traces. So there is offsetting and there is acyclic type of repetition because of this trace. So this represents a fault trace. Because it is vertical, that simply means that because this fault trace is a straight line at the surface, that simply means that this fault is vertical in nature. So there are two sequences we can say which are separated by angular unconformity. In older sequence there are 7 simple dipping beds. They are, if we want to analyze that in which direction they are dipping, we can draw some straight lines onto it. So we can preferably choose any of the bed of older sequence. Now we can draw some straight lines. So let's say that we are choosing this one. Then we can draw straight line passing through these 2 points. Because this value is of 900, so value of this straight line will be 900, and then we need either 800 or 1000. So this is 800 value, which is again intersecting the same trace. So we will draw one more line parallel to this one, and this will represent the straight line of value 800. So dip direction is from higher value of straight line to lower value of straight line. So this is 900, we can see this is 800 and this is 900. So higher value is in this direction, lower is in this direction, means this is the direction of dip. So now we know that younger beds occur in the direction of dip, so we can number these beds as well. So this is our bed number first, opposite direction to the dip. This will be bed number second, this will be bed number 3, bed number 4, this will be bed number 5, number 6, this will be bed number 7. Similarly in this block as well, because fault creates 2 blocks. If there is presence of one fault, then it will create 2 faults in 2 blocks in the area. So this is first one, this is second bed, this is third, this is fourth, this bed is fifth, this is sixth, and this is seventh bed. And in younger sequence we have one bed, we have second bed, we have third bed, and we have fourth bed. So in older sequence we have 7 simple dipping beds, and they are dipping in direction towards north, and the strike of these beds is in east west direction. And we have younger sequence. Now let's determine that in which direction the younger sequence beds are dipping. So either we can choose the trace of unconformity or we can choose any other trace. The only thing we will have to take care is this should be cut by more than one value of contour lines. So here we have one such line, or we can draw over here as well. So this is one strike line. The value of this strike line is given by the contour value which is intersecting this. So this value is 700, and now we need either 800 or 900. So here we have 800 value, and it is intersecting this at 2 points. So what we do, we choose the one which is closer to the earlier one. So this is closer, and we draw parallel line to existing strike line. So here we have one more strike line. The value of this strike line is 800. This was 800, and this was 700, and this is 800. So now the traces are dipping in this direction, and the direction of dip generally we get younger bits. So this condition is also satisfied in younger sequence. So this younger sequence is dipping roughly in north-northeast direction. Now we have determined the dip directions and strike directions for older and younger sequence. We will have to determine the dip amounts as well. So in order to determine the dip amount, what we do, we measure the HE in the section line direction, and then we put CI over it. Here in this map as well, like earlier maps, we have 1 inch is equals to 1000 feet scale. So 0.1 inch will represent 100 feet, and contour interval in this map is again 100 feet. So now we will have to determine the dip amount for older sequence and younger sequence. For that we will take divider and measure the HE value on a strike line. So here is HE. So once we have measured the HE value, we can draw that. Now we can draw CI over HE. So first we are going to draw the HE, then we will draw 0.1 inch onto the HE line. So here we have 0.1 inch, and then we will join these points, and this angle will be the dip angle for older sequence of rocks. So roughly we have 20-degree angle for older sequence. Then we will measure the dip amount for younger sequence. And they are dipping in direction from A to B. Now we will measure the HE for the younger sequence, and we will do the same exercise for a younger sequence. Now we will plot 0.1 inch. So this is actually HE, then 0.1 inch over HE, and it will give us the value of dip for younger sequence. So we can measure this one as well. Now here we can see the value is roughly 15 degree for younger sequence. 15 degree. So now we have determined the values of T for younger and older sequence, and we have determined the structures. We can see that older sequence is Ordovician, and younger sequence is Devonian. We know that order of age is Carboniferous, Cambrian, Ordovician, Silurian, then Devonian. The Silurian is completely missing. It means this was a time when older sequence was exposed for erosion and non-deposition. Then it again subsided in Devonian, so there was deposition of these Devonian series of rock. Devonian series of rock over older sequence. So we got this younger sequence onto the older sequence, and there is gap in deposition during Silurian period. So this Ordovician sequence, that is older sequence, this includes conglomerate, quartzite, grit, sandstone, flagstone, mudstone and shale, and that's how we can also conclude that there are 1, 2, 3, 4, 5, 6, 7 beds. So this symbol is for conglomerate, the second this is for quartzite, and this is for grit, and this symbol is for our sandstone, then we have flagstone, then we have mudstone, and we have shale. And here again we have flags, we have red shale, we have gray shales, and we have sandstone in younger sequence. Now let's draw the cross section. To draw the cross section, what we need is we need the data for the contour and data of data strike and data of traces of bed. So in general what we do, we actually fold the map, but today we are going to use the strip, as this keeps our map intact. So here is point A, this is point B. Now we will mark different positions for different structure. For example, here we have fault as well as bed. Here we have bed, and this is bed number 3. Here we have bed, this is bed number 4. This is bed number in fact 2, and here we have bed number 1. Then we are getting again one bed over here. This is bed number 6. Then we are getting a trace of unconformity at this point, so we will write U. Then we are getting the trace for the bed at this point and trace for bed at this point as well. Then we are getting different value of contours. So I am going to mark the contours with a red point so that they are different from the beds. Here we have one more contour, then we have one contour over here, one contour over here, one contour over here, then we have again contour over here, here. We are not getting any structure or contour. So now, rather than folding this map, we will use this strip for the preparation of map. Let's verify. So here we have bed, bed, bed. We have bed trace, we have fault trace at the same place, we have bed trace, we have unconformity over here, and value of contour over here, the value of contour over here. So let's write down the values as well. This is 1000, this contour is of 1100, and this is of 1200 feet value. This contour is of 800 feet value. Then we can see this contour because this is 800, so this must be 700. So this is 700 and this is 700 value. We are not getting any other contour to mark. So now we will make the map with the help of this strip. We will put the map aside. If needed, we will color the map afterwards, and we will fill the corresponding colors into our section as well. So now let's mark these 2 points, A and B first. That will represent the baseline for the map. So this AB line represents the baseline. First we will make the baseline, and then we will make the heights, and we will project the contours, and then we'll proceed for the making of profile, and ultimately for the cross section. So here is our baseline. Onto the baseline, because the values of contours are varying from 600 to 1200, so we will make at least up to 1500. So here is our 1500. We'll mark some values. Right, so this is 0 feet, this is 200, this is 3, this is 400, this is 5, this is 600, this is 7, this is 800, this is 9, this is 1000, 1100, this is 1200, this is 13, this is 1400. Similarly, we will mark these values in this direction as well. $100, $200, $300, $400, $500, $600, $700, $800, $900, $1,000, $1,100, $1,200, $1,300, $1,400 and $1,500. So here we have 0, then we have 100, we have 200, we have 300, 400, then we have 500, we have 600, we have 700. I am marking alternate odd values in this direction, even in that direction. 800, this is 900, 1000, this will be 1100, 1200, this will be 1300, and here we have last one 1500 value. Then we are going to mark the contour values, and the contour values are going to give us the shape of profile. So here we have 700, 700, then we have 800, we have 1000, we have 1100. So now let's put a scale over here and mark these values above the baseline. So this is 700, here is 700, this is 700 again, so again we will mark 700. Then we have 800 at this point, this will be 800, and here we have 1000, so we mark the value 1000, and then we have 1100 at this point. The next belongs to 1200, at this point. So we will mark the value of 1200. And now if we join this smoothly through the pencil or some pens, they will get the profile. So this is 700, and we can see the trend. The next one will be of 600. So here we will join between 600 and 700. These two are 700, and next one we are getting 800. So one thing we will have to take care that we are going to use smooth hands for joining them rather than joining sharply through a scale or joining 2 points sharply. So this is 1200, the next will be in between 12 and 1300, and here this will come in between 6 and 700. So this is our shape for the profile. Then next what we are going to do is we will draw the fault as well as unconformity, because fault is vertical. So what we have to do, we have to simply mark a straight line at the point where fault is present. So this is representing the fault. Above it we will draw with dissected lines because feature is now eroded, and because we have an unconformity, so this point will be of unconformity. We will mention it over here as well, and these points are the points for the beds. We will mark further with taking dip and strike considerations. So now we have marked the position of beds. The bed is over here, over here, over here. Unconformity is over here. A fault and bed both are over here. And here we have a bed trace, and here we have a bed trace. Because we can see that the bed one is coming over here, so no problems. We have 1, 2, 3, 4, bed 5, 6 and 7. So 5 is coming in this direction, and 6 and 7 are coming in this direction, and other beds are coming in this direction. So the one which will not come, we will draw that by determining the thickness of the beds. So our profile is complete. Now we will go for the drawing of angles onto the baseline. So older sequence is dipping with an amount of 20 degree, and dip direction is towards north, that is from A to B. So we will draw an angle of 20 degree, an angle of 15 degree, and both younger sequence and older sequence are dipping in direction from A to B. Let's take a point. In reference to this point, we will draw two angles that are 15 degree and are of 20 degree. So this is 20 degree, 15 degree, and this is 20 degree. We will join these points. So if we are drawing the beds of older sequence, they will be parallel to this 20 degree angle, and if we are joining or drawing the younger sequence beds, they will be parallel to this 15 degree angle. So better if we mention it, this is 15 degree and this one is 20 degree. Now let's draw these beds of older sequence and younger sequence, and before that let's determine that which is the downthrow direction in this map. So if the maps are there and younger sequence comes in contact with the older sequence, So the direction of younger sequence is in fact down throw direction. So we can see the bed 7 over here is coming in contact with the bed number 5. So younger sequence rocks are coming in contact with the older sequence of this block. So this block will be our down throw block, and this block will be down throw block because this is carrying younger beds to the greater depth. So this block is in fact our down throw block. So the beds towards this direction, they will be going down in comparison to the beds in this direction. And let's now determine that what is the amount of throw. So in order to determine the amount of throw, we will have to know that one trace is present at what elevations in both the blocks. So here we can see this trace is present at 800, 900, this is 800. If we keep on drawing the similar, taking the similar values, we will get the next strike line or value 700. So roughly we should draw this with an equal amount. The next one, we'll draw somewhere here. So we can see that the value of this 700, this will be 600, and this is intersecting this value of 900 roughly. So this is in between the 900, 800. So we have throw equals to roughly 300 feet. We can say 250 feet because it is not intersecting exactly at this point. So this is a bit less than 300 feet. Again, we can also determine the thicknesses of the beds. So we can see that this trace over here is present at 800. This is 800. This is 900. This is in fact 900. So this will be 700 for this one. 800. The next will be, and this is 800. This will be 700. This 600, 500, 400 for this, and 400 is on 900. So the difference will be of 500 feet. So this will be roughly 400 will be 500 feet vertically thick. So if we need the data for bed number 4, then we will use roughly vertical 500 feet thickness for this bed. Now let's plot these beds. We have determined the down throw direction as well. So here we can see this map as well. We are getting this bed, and this is dipping from A to B, and dip amount is 20 degree. So we are going to draw these beds parallel to this 20 degree value line. For that we are going to use either 2 set square or 1 set square and 1 scale. That will also help. So here it is parallel to 20 degree line. Now we will move our set square parallel to this line, and this will give us the position of this bed, and this will not exceed the fault. So we can extend this fault because in ground it is going deeper down. It is present in subsurface condition. It is eroded above the profile, and now we have another bed, and this will again plot parallel to this strike line only. So let's plot this as well. We'll have to take consideration of parallel line. And again we have one bed present over here This will again plot parallel to earlier line. Then we have one bed over here. So one trace we can see of this block is present over here. So this is going to be the vertical thickness, because this is bed number 1, this will be bed number 2, this will be bed number 3, this will be bed number 4. So this is exact vertical thickness for bed number 4. If it is needed, we will use the same value. Then we can see we have these beds, they are dipping in the same direction. So we get these beds, but before that we have unconformity as well, and this unconformity is dipping with an amount of 15 degree from direction A to B. So this unconformity will be parallel to 15-degree line. So let's draw the unconformity. In fact, we are supposed to draw the unconformity first, then we draw the older structure. So here we have unconformity, and the beds which are younger, they will plot parallel to this. So these are younger beds. And prior to erosion, these beds must have been going like this. So we will plot these things with dissected lines which have been eroded. The older sequence beds in this down throw direction, they must be present below the unconformity only. So we will draw them as well. So this is our bed number 4. The direction of down throw is this one, and this block is up throw. So we have an idea that these beds are dipping with an amount of 20 degree, and down throw is roughly 250 feet. So we can use that data in order to draw it. But before that, we have some the value of beds over here. We have 2 traces for the beds onto this line near to the unconformity. We can see here we have A, we have B, and we have 2 traces for the beds here and here. We plot them as well, and that is going to give us the idea about beds in this block. So here we have a bed, and here we have a bed. What we are going to do that we will project them onto this baseline. So here and here, and we will draw them parallel to the older sequence beds. This will plot like this. Another bed plot like this direction. So this is in fact the bed number 6. can see, and here we have trace of bed number 5. Then we will have 4 below the 5. So in order to draw the 5, we need the thickness of 5. So we can determine the thickness of 5 with the help of these straight lines. So here one trace is at this point, and the value of this trace is 900, this is 800, this will be 7, this will be 6. The next will plot that will be of, in fact, 500, and it is intersecting the 900. So we have thickness of bed number 5 equals to 400. So we can draw the 400 value vertically by measuring the 0.4 inch. So here we have bed number 5. We can draw the bed number 5 at this point. Then after drawing the bed number 5, we will draw the bed number 4. So we can stretch these beds within the limits of AB, that is over here and here. Now we will have to draw these points parallel to this 20-degree line. So now in order to draw that, we can take help of this scale. So the line should be strictly parallel to the earlier lines. So here we have bed number 5. Then we will have bed number 4, and this is the vertical thickness for bed number 4. We will measure this distance. From this point to this point, and we will draw the bed number 4. So here from this point we'll have bed number 4, and this will also be parallel to this bed. So here we have bed number 4, and after the bed number 4 we will have bed number 3. So this is the vertical thickness of bed number 3. This will be our bed number 3. Then we will have bed number 2 of this much vertical thickness. So this is where bed 2 will plot parallel to this line. So this is position for bed number 2. Then what we are going to do? We are going to draw the beds. This is in fact the point for the bed. So rather than this line, the well bed will plot over here. So this will be real position for bed number 2, and this line we will remove, and similarly we will change the thickness another block as well. So here this line will shift because thickness of bed 2 is somewhat more than we expected. So we are going to plot this much amount from this point. So here is the position for bed number 2, and of course it will plot parallel to the older sequence beds. Now once we have drawn all the structures, we will draw them with some permanent pens. So here is our fault. It's a vertical fault. Then above we are going to draw it by dissected lines. Then these are our different beds. We can extend the structures below the subsurface because they are already present in the subsurface regimes. They are eroded from above the profile. So here we have upper trace for the bed number 1, and in this block we have upper trace for the bed number 1 over here. We have upper trace for the bed number 2, that is lower trace for bed number 3 over here in this block, and for bed number 4 the lower trace is this one, and this is upper trace for the bed number 3. Similarly in this block as well, this will be upper trace for bed number 2, lower trace for bed number 3. Below the profile that we plot like this. This is trace for unconformity. We will mark it with zigzag line, and these are younger sequence which are relatively less tipping in comparison to the older sequence. There is a 5-degree difference. It means when the bed was uplifting, that was our younger sequence, this sequence got tilted for 5 degree, and when the deposition occurred while uplifting, the rotation occurred in same direction with an amount of 15 degree. So this is our profile. Then we will remove the excess data and we will fill the symbols. So this is A, This is B for the baseline. Exact point at A and B are over here. And below AB, if we slice down this area along this direction, this is how the structures will look like. Then we are going to remove the excess things and even the baseline, so that now we have clarity in the structures and different bits. Now what we are going to do, that we are going to give colors in the map, and the same color we will use in this section as well. So here we can see that this is our down throw direction, because beds are going down in this direction, and this is throw direction. This is a fault. Now we will fill the symbols in different beds. So conglomerate is represented by this type of symbol. Because the base of lower bed is not known, so we consider this is unconformable, and here we have first bed. Then together with that we will also use some crayon colors so that it is clearly distinguishable. So let's color the first bed with brown color. And we will use the same color now in the section line as well. So this is now our conglomerate bed, and this will be bed number 1 in section 9. We are going to use the same color in section 9. So this is the point up to where we can color the brown, fill the brown color. We'll fill right so that other details are clear. And this basement is unconformable, of course, for the bed number 1. Now we will use some another color for bed number 2. Let's say we are going to take yellow color. We're going to fill in the map as well as in section 9. This is bed 2. Over here we will also fill the symbol for bed 2, that is quartzite. So in second bed we'll fill the yellow color, and this is our quartzite. The third bed is of grit, and it is represented by some denser dots. Then we are going to use some colors. Let's fill. Let's say this is orange color. So we are going to fill orange color over here, fill as here. And the third one, the quartzite, second one, the quartzite, that is yellow. So now we will fill the similar color in the section line as well. So this will be orange. This is our third bed. Then we have fourth bed, that is our sandstone bed, and it is represented by this type of symbol. We will fill some color in sandstone. Now let's use for sandstone I am going to use the deep blue color. So this is our sandstone. We'll fill the same symbol in this map as well. So it is represented by some coarse dots. together with some fine dots in it. In the section in the map we have given it blue color, so we will use the same color in the section as well. Now for bed number 5 we will use some different color, like I'm going to use red color for the bed number 5. Fine dots with red color. And the same color we will fill. So bed number 5 is in fact our flagstone. So let's fill the symbol for 1, 2, 3, 4 and bed number 5 over here. So it is represented by fine dots as well as red color. Let's fill these fine dots first. And then we are going to fill red color. Here we have fine dots. And we are going to leave the bed number 3 uncolored, or bed number 6 uncolored, with only putting the dots in it. So we will fill only dots in our bed number 6. And this trace represents the unconformity, so this one is an unconformity plane. We are going to mark it by zigzag line once we have filled this symbol. So this is mud stone, and then bed 7 is given a symbol 3 dots, so we will fill this 3 dot symbol. Then we will fill colors in the younger sequence as well, but prior to that we will mark the unconformity in this plane. So to mark the unconformity, we will use So this is trace for unconformity. This represents the distinction between older and younger beds. Below this we have older beds and above it we have younger beds. So let's color this sequence as well. So I will put light green color in the bed number 7, the map, as well as in cross section. And this is shale, and these all beds of older sequence, they are Ordovician in age. So here we have this bed in green color, shale bed. Now we have younger sequence above this unconformity, and we are getting only 3 bits of younger sequence. We are not getting fourth one. Well, it is a younger one. If we would not have been getting the first or second, we would have been getting the third one, then we needed to determine the thicknesses of these in order to draw it. So now we'll leave the first bed colorless, that is flag, and in second bed we are going to use this purple color, this is bed Q, and that is in fact red shell of Devonian age. And we will fill the same symbol in our second bed over here. Together with this we have some dissected lines in it that we will fill. Now in third bed we will fill the symbol without any color. So this is our third bed for the younger sequence. So this is our map, and for this map we have derived a cross section, and we have drawn a cross section across or along the AV line, and this is the cross section. So now we can interpret the geological history of the area. We have older sequence separated by an unconformity from the younger sequence, and this is an angular unconformity. The older sequence is consist of 7 beds of Ordovician age. These beds in Younging age are conglomerate, quartzite, grit, sandstone, flagstone, mudstone, and shale beds. Then we have 4 beds in younger sequence, and they are represented by lithology's flag, shale, that is red shale, grey shale, and sandstone in order of Younging. Then let's reduce the geological history. So bed first of the older sequence, that is conglomerate, it was deposited unconformably over an unknown basement, followed by conformable deposition of quartzite, grit, sandstone, flagstone, mudstone, and shale. Then this all deposition took place in Ordovician age. Then area was uplifted, tilted through 5 degree in the direction AV, and it was exposed for erosion during Silurian time that led to the development of angular unconformity. Then the area again subsided in Devonian, and deposition of bed first, that is flag, took place over this unconformable basement unconformably, followed by conformable deposition of red shale, grey shale, and sandstone bed. in this area. Then the area was again uplifted and tilted through 15 degree more in the direction from A to B, that is in southern direction. So the dip of older sequence becomes 20 degree and dip of younger sequence became 15 degree. Then the area was again exposed for erosion, and that led to the development of this present day landscape. So we have interpreted geological history as well. So now let's summarize it within 4 points, and those 4 points are in fact first point is topography, the second point we discuss is structure, third point we discuss is order of superposition, and fourth point we discuss is geological history, which we have already discussed. So topography, we have already defined that the minimum height of this area is more than 600 feet but less than, or we can say more than 500 feet but less than 600 feet, because 500 feet value contours are not there. And the maximum elevation of this area is more than 1200 feet but less than 1300 feet. And the elevated areas are towards the southern portion of this map, and these areas are a bit less elevated, or lower relief is in the southern direction and higher relief is in the northern direction. And in the structure there are two sequences. They are differentiated by an angular unconformity. Older sequences consist of 7 simple dipping beds which is faulted. A vertical fault is present over there, and the younger sequences consist of 4 simple dipping beds. And older sequence is also characterized by presence of a fault that is a pre-unconformity fault. So this fault is pre-unconformity fault because it is not affecting this sequence. So while upliftment of younger sequence, so during or after upliftment the area was faulted as well, then it was exposed for erosion, then there was development of unconformity. So these are the structures present in this area. If you want to know about the order of superposition, so there are 7 beds in younger sequence. So we'll have to draw 1, 2, 3, 4, 5, 6, 7. So the first bed, that is conglomerate, then we have quartzites, then we have sandgrit, then it is followed by sandstone, then we have flagstone, we have mudstone, and we have shale beds. Then we have an unconformity, and we have younger sequence above it. So there are 4 beds, 2, 3, and this is 4. So this is first, this is second, this is third bed, this is fourth bed of younger sequence, and there is presence of fault, and fault is present in older sequence only. So this will be the fault. It is not affecting the younger sequence. So this is our order of superposition. Of course, in the files we will be filling these symbols accurately. Now here the second bed is purple color, so we are going to fill this symbol second bed over here as well. Then we have geological history. So we have already interpreted that this conglomerate was deposited unconformably over unknown basement, followed by conformable deposition of quartzite, grit, sandstone, flagstone, mudstone, and shale of Ordovician age, that is of older sequence. Then the area was uplifted, tilted, and faulted during or after the upliftment. Then it was exposed during the Silurian, because these sequences are Ordovician and these are Devonian. So there is missing sequence during Silurian, means this older sequence was uplifted during the Silurian, so there was only erosion and non-deposition. So that led to the development of angular unconformity, and the area was again submerged, and there was deposition of bed first, second, third, and fourth. So first was deposited unconformably over that angular unconformity, then there was conformable deposition of bed second, third, and fourth of younger sequence. Then the area was again uplifted and it was tilted through 15-degree mode in the same direction, that is in northern direction, and then area was exposed for erosion, and that led to exposure of these beds at different places and gave rise to the present day topography. So thank you everyone. Today we learned this map. We deduced or we drawn the profile and cross section along line AB for this map that represented two sequences, older and younger sequence, and an unconformity of Silurian age, and we got this section for this particular map. In the next class we will be learning a bit more complicated map. Thank you.